cell equation, then you have E cell, or it can be applied for the cell as well as for half electron. For both it can be applied. Okay, E cell equal to E naught cell. E naught cell is the standard EMF plus RT by NF. R is the gas constant, okay, and T is the temperature in Kelvin. Okay, N is the number of moles of electron transferred between cathode and anode. Okay, as per the equation. These are the A and B are the reactants, and small a, small b, small c, small d are the coefficients. Okay, so RT by NF, ln, this is reaction quotient. Okay, Q, which are same expression as the equilibrium constant. Okay, but the concentrations which you have taken are not the, they are not the concentrations are not equilibrium concentration. If you take equilibrium concentrations, it becomes equilibrium constant K, right? So this I hope is clear to you. Okay, so you need to find the EMF, original EMF of the cell, and the current EMF will be given as per the concentrations which is given to you. Right, this is the expression. Concentration of solids should be taken as 1, right, and accordingly you can calculate. Okay, so this question we did last time, or any idea? We did it. Okay, so this is, so without writing the Nernst equation you can do it very quickly. Just you need to check whether the whatever the change which you have done is going to take the reaction in the forward or in the backward direction. Okay, so let me add some more questions. So standard hydrogen electron. Okay, that is, what is the electrode potential of a standard hydrogen electron? It is 0. Okay, under standard condition. It is 0 volts, right? So these are the standard conditions. Pressure 1 bar, temperature 298 Kelvin. Okay, but this is not the standard condition. What is the electrode potential of hydrogen electrode? Okay, at the given temperature, given concentration, but the concentration is not given actually. They have given the pH. So I hope you understood the question. So just try it. Understood the question? So what is going to be the electrode potential? That we need to find out. Okay, so this is, so concentration is not given. Actually, instead of concentration, pH is given, and you know from your class 11th that the concentration and pH are interrelated. So we can convert very easily. Okay, first you need to write the electrode potential. Okay, the Nernst equation. So any idea how you are going to do it? So EMF or electrode potential of hydrogen electrode is equal to the electrode potential of standard hydrogen electrode, but this is zero, so we don't have to worry. Okay, but first write the equation also what is happening. So 2H plus giving 2 electrons to give H2. Yes, okay, this is the equation, right? So how you are going to do it now? Tell me. Write the Nernst equation. So minus, that is going to be 0, minus 2.303 R into T by N into Faraday's constant, and log of concentration of product. If you have gases, take the partial pressure of the gas, okay, divided by the concentration of H plus ions, each raised to the power stoichiometric coefficient. Okay, so it is 2. Clear? Right? So tell me quickly, what are we going to get as answer? This is 0 and 2.303 RT by F value we already calculated. That is, I told you 0.0591. So 5.9 you can take it 6. It will make the calculation easier. Electrons are 2. Log of partial pressure of hydrogen is 1 bar by H plus concentration square. Log 1 upon X, if the something will come to the, if something comes into the numerator, okay, so the sign is going to change. Is it clear? Memuna, are you getting? Any doubts in this? Right. So this is 0.03. I have divided it by 2. And this H plus is going to come at the numerator. So minus 2, power is going to be 2. It is going to become minus 2 once it comes. And power is going to come in the front, minus 2. There was already one minus, this minus, minus 2, H to the power minus 2, and that is going to come in the front. And log H plus. Power comes, the power of concentration is going to come in the front. So 0.06 minus minus plus log of H plus. Okay. And what is pH? Tell me. pH is also a concentration of H plus ions, but it is the log of the concentration of H plus ions. Okay, minus log of concentration of H plus ions. and the pH is given as 2. So log of H plus ion is equal to -2. Okay. So 0.06 into -2, it will be equal to 0.12 minus 0.12 volt. Is it clear?
Yes.
Okay. Just be careful. Actually, there are a lot of places where we can go wrong. The sign are there. Okay. The powers are there. So be careful. Right. So next is the relationship between the EMF of the cell. Okay. And the Gibbs free energy change and the equilibrium constant. Okay. How we are going to find it out? Yeah. So just now we have seen this was a Nernst equation that you know. E cell will be equal to E naught cell minus 0.0591 upon N log of reaction quotient. Okay. Suppose at equilibrium, what is going to happen? E cell will become 0. Okay. Because at equilibrium, the cell stops working. But E naught cell is the standard that is not 0. Actually, that is fixed. Okay, that doesn't that is calculated from hydrogen electron. Okay, so it is not going to be 0. It is just fixed. It has a fixed value, right? So, and at equilibrium, the reaction quotient become equal to K. It is known as equilibrium constant that you must have studied in your class 11th. So what we can do is we can write log of K. I will put K here. Okay, this was 0 equal to E naught cell, okay, into N by 0.0591. Is it clear?
Yes.
Right, that's how we are going to do it. Okay, from the Nernst equation you can calculate. Okay, this is the formula which you can, this value is RT by F is 2.303 RT by F. Okay, that you can put the value. Okay, so this equation is same, but I have put the value 0.0591 in place of those constant RT by F and all, right? Clear? So, and what is the relationship between delta G naught? Delta G naught and EMF of the cell. Any idea? So you have completed your boards. So just board, in board you have studied this chapter, right? So just tell me what is going to be the value for delta G, and so if you forgot, no problem, we will derive it. Delta G and E cell. Yeah. Tell me. Okay. Just remember this. Suppose if EMF of the cell is positive, what's going to be the sign for delta G? Tell me. Is it positive or negative? Yeah, Memuna. If EMF is positive,
Positive.
yeah, what can you say about the reaction? Is the cell reaction going to work, or is the cell reaction is going to stop? Is it spontaneous or non-spontaneous?
Non-spontaneous.
If EMF is positive, means the cell will work, but the cell is giving us voltage. Okay. And the cell reaction is going to work, means it is spontaneous. Right? If EMF of the cell is positive, means the cell is going to work. It's going to give us the voltage, and the cell is spontaneous. Right? Reaction is spontaneous, means it can happen, it can occur on its own. That's why we are getting the voltage. Okay. Clear?
Yes.
So, and if the cell reaction is spontaneous, so do you remember from 11th actually what is going to be the sign of delta G? Gives free energy change. For a spontaneous process. Actually, the process which can occur on its own, the gives free energy change is negative. Okay. So gives free energy change is negative, means EMF is positive, and the reaction can happen on its own, and we will get the EMF. So you can look from this side, EMF of the cell is positive, and this whole thing is negative because there is a negative sign over there. Is it clear, Mamuna?
Yes.
This is the most important thing. Okay. And what about this one? Suppose if the EMF is negative, what does this mean? Suppose if you are given with a cell equation and the EMF which you are getting is negative, what it means? It means the cell is not going to work. Okay. Cell is going to work only if you have positive EMF value. Okay, the cell is not negative EMF means the cell is not going to work. Cell reaction will not work. Okay, cell will stop working. So it is non-spontaneous. Right? And the gives free energy changes positive. Is it clear? Do remember this, very, very important. I hope you understood this. The reaction will, the cell will work only if the gives free energy is decreasing. And the gives free energy is going to decrease if the EMF is positive and delta G is negative. Okay. Clear? Amuna, is this clear? How
Yes.
is it positive? Delta G equal to minus NF E cell. Okay, so E cell is negative and the whole thing is negative, negative will become positive. Okay. So delta G, calculation of delta G will help you to make out how much work you can obtain from a cell. Okay, how much work, and what will happen at equilibrium. What happens at equilibrium? Equilibrium means where the reaction is happening. Is it happening in the forward direction or backward direction? Tell me. Yeah. At equilibrium. Equilibrium means the reaction is happening in both the directions equally. Okay. At equilibrium means the reaction stops. Actually, it is occurring in both the directions with the same speed. So we think that the reaction has completely stopped. Right? Clear?
Yes.
So reaction is stopped, and delta G, there is no Gibbs free energy change, equal to 0. If Gibbs free energy is decreasing, then the reaction will proceed in the forward direction. If Gibbs free energy is increasing, then the reaction will not work, the cell will not work. And if the Gibbs free energy is neither decreasing nor increasing, okay, means what? EMF of the cell is 0. And the Gibbs free energy change is also 0. Clear? So I hope you understood that this is the first thing which you should know. First thing is this one, right? This is the most important thing. Okay. Then you have this one. What is the relationship? So this is the Gibbs free energy and EMF of the cell. This is the direct relationship. The EMF of the cell and the Gibbs free energy have opposite sign. If the EMF is positive, the cell is going to work, and the Gibbs free energy is going to be negative. Change is going to be negative, the cell is going to work, right? So that is the most
Yes.
important thing which you should know. The other relationship is this one. This is the second relationship. Okay. So if you understood this, then the second relationship, and the second relationship is can be derived from the Nernst equation. Just now we have seen that at equilibrium, cell stops working, E cell becomes 0. And Q become equal to K. So this is 0. I will take E naught on the left hand side. Minus minus will get cancelled. You will have NF E naught upon 2.303 RT equal to log of K. Okay, log of K is equal to this one. So log of K, actually this is ln, which is base E. If you change it to log, it is, you need to multiply it by 2.303. Okay, that's what I have written. You can calculate the log, or ln. Ln is means log to the base E. Log means log to the base 10. So you can use any one of them. Okay, clear? So log K equal to NF E naught by 2.303 RT. You can get this. You can write this formula. Okay. And from this, from the standard EMF of the cell, you can calculate the equilibrium constant of a reaction. Is it clear?
Yeah.
This is the second one. And the third one is delta G not equal to minus RT ln K. Okay, this is, you can use, remember any two, you will can derive any three. Okay, so let's do this. So electrical work is the work done by the cell. Okay, and it is minus NFE cell. Okay, that's we already we discussed. Okay, so this already I told you. Any doubt in this? Just have a look. E cell positive gives free energy change negative. Cell reaction is going to work. E cell is negative, gives free energy is increasing. The cell is not going to work. EMF of the cell and the delta G have opposite sign. Okay, they have opposite sign, right? Clear? So this is all what we derived just now. Okay, so you can calculate this. This is the basic question. You can just try it. You can write the overall equation, from that you can calculate. Just try it and then we will do. So what's the Gibbs free energy change for the overall process?
Option C.
Option C. Okay, let's take the answer. It's option A. So net process you need to write. Okay, so this is anode cathode. Okay, this is, so which one is going, so both are reduction potentials. Okay, which one is going to be anode, which one is going to be cathode? Tell me. The one who has higher tendency, both are shown in reduction. Both are accepting electron. But who is accepting electron actually? Is it the H plus or iron? So which is having the higher value of EMF? This is higher, larger value. This is smaller value. Okay. This is cathode. This is anode. Okay. So how you are going to make the equation? E cathode minus E anode. Okay. So what's going to be the EMF of the cell? E cathode minus E anode, and this is already minus, so minus minus is plus. It is going to be 1.67. Okay, right? Clear? And the delta G naught for this is minus NF E naught, sir. Is it clear? So how we are going to do it? So just for the overall reaction, you need to have the formula, right? Complete formula you need to write. You need to calculate the EMF. Okay. So just calculate the EMF of the complete cell. That's it. So now what we are going to do? So EMF is positive, delta G is minus N. What is N? N is 2, it is already given. If it is not balanced, you need to balance it to get the number of electrons. Okay? Clear? And N is already balanced. F is 96. F is the charge of 1 mole of electron, and EMF is 1.67. This is in joules. Okay. So you need to multiply it and you will get 321. Take 1000 out kilojoules. Actually, this joule and kilojoule, you should be very careful. This is the most common mistake. Right? So I hope you are able to understand this. Okay. Basic question, very important. Okay. Any doubts in this, Vemula?
No.
Okay. So let's do another question. Cell reaction involving 2 electron change. Yeah, N is 2. They have given you. Okay. Standard EMF of the cell. EMF also they have given. In the above question, cathode anode was given, so EMF was not given. So EMF is given at 25 degrees Celsius. The equilibrium constant for this reaction they are asking. Okay. So I hope you understood the question. So what was the relationship between the equilibrium constant K and EMF? Either you need to remember it, or if you forget, you can derive it from the Nernst equation itself. Yeah, tell me. Yeah, what was the relationship? Just go back, or we can derive it again. Suppose if you forget, so then how you are going to work it out? E cell equal to E naught cell minus 2.303 RT by NF, okay, log of Q, reaction quotient. At equilibrium, E is equal to 0 and Q equal to K. Just put it like this. Is it clear? Because whenever there is equilibrium, the cell stops working. Mean the reaction is not going in any other direction. Right? So it stops. So what's going to be the log of equilibrium constant equal to N F E naught. Minus is going to get cancelled because it is going to come in the left hand side. Okay. 2.303 RT. Okay. That's going to be the value of log K. Okay. Is it clear? So NF E naught, N is already they have given 2. And E naught they have given 0.295. Understood? 2.303. Okay, this or this, no need to put all the values. Okay, just you can show it. Actually, 2.303 RT by F. Whole thing was having value of 0.00591. Though you can write it 8.314 into 298. Okay, whatever the temperature is. But you should know that N E naught by whole thing, the 2.303 RT by F. Okay, we used to put it over here 0.0591. 0.06 I will write. That will make my calculation easy. Okay. Clear? 0.0622 E naught F and all that is already been simplified. 0.06 I have written. Okay, that is equal to log K. So how much is it going to be? Tell me. Just try it quickly. Yeah. Getting the answer? Yeah, Memuna. 2 into
Yes.
E 0.295. What will be the answer? Tell me. By 0.06. What is the or 2 into 0.295 divided by 0.0591. Okay, this was the actual value. So what is 295 into this? It is how much? It is 5 into 2, 10, 9 to the 18, 18 and 1 9. 5 to the 10. Okay. 9 to the 18, 18 and 1 19. 4 and 1 5. Yeah, okay. It is 0.59 and this is also 0.059. Okay, clear? So this is how much? One, this will get cancelled. Yeah, how much is it going to be? Yeah, tell me. What's going to be the value? Yeah, Memuna.
Option number A.
Yeah, it is option A. What you can do is you can multiply it by 10, divide by 10. Okay. So it is 0.91 and 10 will go up. So it will become 10 only, right? And log K is equal to, so this is the value, this is 10. Okay. You multiply it by 10, it will 0.591 and 10 will go up. Okay, this one. So, okay. So that is log K. Okay. So K equal to 10 to the power 10, right? Actually, what you do, you raise the power. Okay. 10 to the power 10. Okay. Clear? Right? Understood? Is it clear? So it is C. Option C. Okay, this will get cancelled. So let's move to electrolysis. So I hope you understood everything. Yeah. Understood? This one, this is very, very important to keep this in mind. Okay. Right? And what is electrolysis? Now let's move to electrolysis. Okay. Yeah. What is electrolysis? Tell me. What is the difference between the electrochemical cell and electrolytic cell? Yeah. Electrochemical cell, the reactions were happening on their own. Okay. The reactions were occurring on their own. Clear? And we were getting the EMF. EMF we were getting as positive. Okay, we were getting the positive EMF values. Okay. Clear? In electrolysis, the reaction doesn't happen. Okay, the reaction doesn't happen on its own. The reaction is non-spontaneous. Okay, and the EMF is negative, right? EMF is negative. Suppose this one, the EMF is negative, right? Clear?
Yes.
So these are the reactions which do not happen on its own, but we put electrical energy, okay, to make them happen. Electrical energy causes the non-spontaneous reaction to occur, and the process is known as electrolysis. Is it clear?
Yes.
So these are non-spontaneous reactions. But why someone will waste electrical energy to do non-spontaneous reaction? What's the reason? So electrical energy will be consumed. Okay. And but why someone will put electrical energy to carry out these non-spontaneous reactions? Tell me. Actually, these reactions are used to generate some chemicals. Okay. The chemicals, these are used to produce chemicals which are not obtained in nature, which are not found in nature. Okay, which are not found in nature. It is used to produce chemicals. Okay. So sodium and chlorine are prepared from the electrolysis of NaCl. Is it clear?
Yes.
So why someone will waste electrical energy? Someone will waste it is not waste of electrical energy. Actually, they are producing the chemicals. Okay. So many chemicals are produced by electrolysis only. Okay. Clear? So molten NaCl, and but the product depends upon, so in this you got Na liquid and chlorine gas. The product nature of the product depend upon the medium, okay, medium taken, and the substances which are present, whether it is water, whether it is molten, okay, depending upon that, okay, the nature of the product of electrolysis is governed. Okay, so molten NaCl, Na metal and chlorine gas, okay, and because the EMF was coming out to be negative, so it is not going to happen on its own. Okay, you need to provide energy, but you need to put energy, and that must be 4 volt or more, then only it will happen, right? Clear? I hope this is clear to you. Molten NaCl electrolysis, so the reaction is going to split into two parts, anode and cathode. Anode, actually Cl minus is going to come in and lose electrons, and cathode, it is the sodium which is going to get reduced at the cathode, and you are going to get sodium liquid. Is it clear?
Yes.
So now we can measure how much amount of substance is produced from how much electricity. Okay, in the last section, we calculated from the concentration of ions, we calculated how much EMF was generated, how much voltage we obtained. But in this one, we are not generating EMF. Actually, we are putting the EMF and we are getting the compound. So how much compound is going to form? What is the weight of the compound, that we can calculate. Okay, and that is given by Faraday's law of electrolysis. Okay, so what is the first law of electrolysis of Faraday's? Tell me. Yeah. What is the first law of electrolysis of Faraday's electrolysis? First law. Yeah, tell me. Very easy. Just you can try. If you don't know, no problem. Yeah. What is the first law of electrolysis? It is very easy. The mass of the substance which is deposited or which is formed. Okay, you are forming this like sodium and chlorine. It is directly proportional to the quantity of the charge passed. Is it clear? Right? So W is the mass of the substance deposited, and it is directly proportional to the charge. Is it clear? Q. Okay, and the charge is I into T. It is ampere into the time. Time should be in seconds. Okay, to calculate the amount of charge passed. Okay, so how much amount of substance is going to form? The amount of substance which is going to form is directly proportional to the amount of charge which is passed through the electrolytic cell. Okay, so W equal to Q. Okay, is it clear? And Q is IT, I into T. And what is this Z? Tell me. Yeah, Memuna, what is Z? Remember?
The equivalent of an element.
Yeah, it is electrochemical equivalent of a substance. Okay, so this is it looks very complicated. Electrochemical equivalent of a substance. This whole things look very complicated. Okay, so what it is, right? What it is, just let me be very simple. So first of all, remember it, W equal to ZIT. Okay, W is the mass of the substance formed. I into T is a current and time. Okay, W is the mass of the substance in grams. W equal to ZIT. Okay, Z is the electrochemical equivalent. And how will you define it? Very simple. Suppose if you pass 1 coulomb of charge, 1 coulomb means 1 ampere for 1 second. Okay, if you pass 1 coulomb of charge, 1 ampere for 1 second. Okay, so this is going to be 1, right? Everything on the right hand side is going to be 1 and W. So whatever the mass, so this is W equal to Z. So Z is the mass of the substance. You can write the definition. It is deposited when you pass 1 coulomb or 1 ampere of current for 1 second. Is it clear? That is the definition of Z. So it is the mass of the substance deposited when you pass 1 coulomb of charge. That is 1 ampere of charge for 1 second. So I hope this is clear to you, right? Any doubts in this? And how you're going to find it out? It's very simple. Z equal to E by F. Right? Z equal to E by F. E is the equivalent weight by Faraday's constant. Equivalent weight is molecular weight upon N. N is the charge, the electron which is being lost or taken by the ion. And F is the Faraday's constant, its value is 96500. Is it clear? So what is the, suppose copper. So what is the value of Z for copper? Its molecular weight is 63.5. Tell me. Yeah. So Z equal to E by F, or you can remember it E equal to Fz. Okay, Z for copper is equivalent weight of copper by Faraday's constant. Equivalent weight is molecular weight of copper divided by Faraday's constant into N. N is the electrons which copper will take. Okay. So copper is going to take how many electron? 2 electron. 63.5 by 2 into F. Is it clear?
Yes.
So suppose if I give you how much copper is deposited, if I pass 2 ampere current for 5 seconds. Tell me, how much copper is deposited from CuSO4? Yeah. Just calculated W equal to, how you are going to do it? ZIT, okay? ZIT, okay? W equal to E by F IT, okay? W equal to E is the equivalent weight, molecular weight. NF IT, okay? So what is the molecular weight of copper? 63.5, that I've given already to you. From copper sulfate, copper is +2. Yeah. So tell me how much is it going to be? 63.5 by 2 into 96500 into 2 ampere for 5 seconds. This is going to be 10. This is this. Okay. Clear? So it is going to be 63.5 divided by 9650 into 2. So 50, I will multiply it. Okay. 5000 100 and 6 to the 12 13 9 to the 193. Okay. So it is 63.5 divided by 193 into 10 to the power minus 2 grams. So you can simplify it and you will get the answer. But you will get the answer, but actually the main thing is you need to know how you have done the process. Is it clear? Understood? Any doubts in this? Faraday's first law? Very simple. W equal to ZIT. Z is the electrochemical equivalent. Okay. And Z equal to E by F. E is the equivalent weight. Equivalent weight is molecular weight by NF into I into T. Time should be in seconds. Okay, that you should remember. So it should not be in minutes, right? Okay. So this is the way in which you can, suppose if you are taking AgNO3, it is AgNO3 is Ag plus. Molecular weight is 108 divided by 1 into F. This is F. Okay. Copper 2 is 63.5 into, this is wrong, 2 into F. Okay. Clear? And what is the second law of electrolysis? Yeah, tell me. What is the second law of electrolysis? Tell me quickly. Yeah. So second law actually, suppose if you have different electrolytes, okay, look here. And when you are passing, when you have connected them with each other, when the same amount of current is passing through all three of them, Okay. The mass of the substance which is going to get deposited is directly proportional to their equivalent weight. Okay. That's what the second law is. So you can, if you know the first law, formula for the first law, you can derive it very easily. Okay, how you are going to derive it? So mass of Ag deposited, mass of copper deposited, and mass of aluminum deposited. Okay, it is ZIT, 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 Z. IT is same for all because the current is same. Understood? I into T is same, the current is same, but the Z is different. Z equal to E by F. F is same. So only the equivalent weight are different. Equivalent weight equal to molecular weight by N. Just write molecular weight by N. Molecular mass by N. So the amount of substance which is deposited in the first cell is directly proportional to 108 by 1. In the second cell, it is proportional to the equivalent weight of copper. Equivalent weight of copper is 63.5 by 2 because copper is plus 2, and the equivalent weight of aluminum is 27 molar mass by N factor. N factor is Al3 plus. Okay, it's Al3 plus. Okay, so 27 by 3. So mass of the substance deposited in each cell is directly proportional to its equivalent mass. Okay, this is the second law. I hope you understood it. Yeah, Memuna?
Yes, sir.
Any doubts? Okay, this is derived from the first law. You can use the equation of the first law. Okay, you can use the equation of the first law to get the answer. Okay, so just write IT is going to get cancelled because it is going to be same. Is it clear? So let's do some problems. Yeah. Yeah, tell me what's going to be the answer to this one. Electrochemical equivalent of silver. Direct question. Just try it. What is the value of Z for silver? What is going to be the right answer?
B.
Yeah, 108 by NF. N is 1 for silver because it is most common oxidation of state of silver is +1. Yeah, so 108 by 1F. Okay, very good. So B is the right answer. Okay. What about this one? So how much quantity of electricity is required to deposit silver from 250 ml of 1 molar AgNO3? Yeah. Tell me. 250 ml of 1 molar AgNO3 solution. So you want to suppose you are given with just 250 ml of a solution, okay, and that is 1 molar. And suppose if I ask you to take all the silver out of that solution, that silver is in soluble form, okay, that is dissolved, okay, right? So if it is dissolved, how you are going to take it out? You are going to do the electrolysis. And with electrolysis, the silver is going to get reduced and it is going to get deposited. Is it clear?
Yes.
So, but so how much silver is deposited? What is the weight? First of all, because you need to apply the first law. So first law tell the weight is directly proportional to the amount of electricity passed. So what is the weight? Yeah. What is the weight of? So first can tell me what are the moles of the silver? Mole says molarity into volume in liters. Understood?
Yes.
So how many moles? Volume is how much? Is it 1 liter or 1/4 of a liter? Is it 1 liter or 1/4 of a liter?
1.
Yeah, 1/4, 250 ml. Okay. So how many moles into 1 mole? Molarity into volume is moles. So 0.1/4 of a liter is 2.25 moles. Okay. So how much silver you want to deposit? 0.25 moles. And what is the mass of the silver? Mass is moles into molar mass. 0.25 into 108. Clear? That is a mass in grams. M or W, okay, which need to be deposited, right? Is it clear? And now, so this is the left hand side of the equation. Now come to the, what is the quantity of electricity passed, okay? So now we will apply W equal to ZIT and W is 0.25. So don't simplify it. We will into 108. And what is Z? Z equal to E by F. Equivalent weight is molecular weight by 1. Just now you told the right answer in the previous question, okay, for the silver, into Q, because it is asking not the current and time, it is asking coulomb. So just I will write it as Q. I into T equal to Q. 108 will get cancelled. Q equal to 0.25 into F. You can calculate it. It's very easy. Tell me what's the answer.
B.
Which one? B. So
Yeah.
you need 96500 divided by 4 because 0.25 is 4. So let's check the answer. Yeah, correct. Very good. Okay, right?
Yes.
And suppose if the time is there, then the current is time, always take it in seconds. Okay. So let's do this. So molarity and volume are given. You can find the mass of the silver, okay, which need to be deposited. Moles you can find out. And the current is there, I into T, time in seconds. That you need to calculate. The answers are only in the multiples of 10. So I think it should be the data is given is very easy. Just calculate it and tell me. What answer are we going to get? Yeah, Memuna. Yeah. Which one? B, C, D. C. Okay. So let's check the answer. No, not C. Just check your calculation. It's option B. Okay. So W equal to ZIT. Don't put all the values. Okay. So W is how much? W is mole into molar mass. Moles is 0.125. Okay, it is in liter is 0.125 into molarity mole into 108. 108 is the molar mass of the silver. Okay. Into Z, Z equal to equivalent weight by NF, molecular weight by NF, equivalent weight by F. So 108 into 1 into F. Okay, into I is 241.25 into T. Okay, T I need to find out. Let's cancel them one by one. Okay. So this is 0.125 into F divided by time is 241.25. Okay. So and F is 96500. Okay. Coulomb per mole. So if I multiply it by 4, so how much I'm going to get? Okay. So it is 5. 4 4s are 16 and 4 2s are 8 and 9. I'm going to get 965. Okay. So 965 into 100 is 965 and 965 this is 1/4 of 965. Okay. So I can write it as 1/4. Okay. Of 965. You can calculate it slowly. Okay. I did it very quickly. So it is how much? 12.5 into 4. This is 12.5 into 4 is going to go in the numerator. That is going to be how much? 12.5 into 2 is 25. 25 into 2 is 50. 50. Clear?
Yes.
So I hope you understood where you made the mistake. Okay. Let's do this. Yeah. So when the electric current is passed through acidified water for this much time, this much hydrogen ML is collected at the cathode. What is the amount of current pass? Yeah.
Option
Option
A.
option A. Okay. Option no. Option C. What you need to do is you need to calculate. Okay, how many moles? 22.4 liter is 1 mole. Okay, that you know. Molar volume.
Yes.
So these are how many moles? One by